5.6 exponential equations and the logarithmic equations. Before we solve for example, we understand there's some rule. We need to use that to understand the concept before we solve for the equations. So the first theorem, we call it when you have the base b of the power x equal the base b of the power y, then your x will equal y because the base b number, they are the same on both sides. But you have to make sure your b, the base b, cannot be equal 1. The base b cannot be equal 0. Another rule is the logarithmic equation. When you have the log base a x equal a log base a of y, then we can let the x equal y because the log a x, log a and log a we can cross out. Same way, there is a sum priority. We have to make sure. For example, here, the base a cannot be equal 1, cannot be equal 0. For the x and the y, these two numbers, they cannot be equal 0, and they cannot be a negative number. So when you solve for the logarithm equation, you need to plug in back the result back to the equation to do the test. And make sure the result will not make the x portion turn to a negative number or turn to a 0. Same way with the y portion here. Solving for the logarithm equation, these three different properties we use most of the time. So the first rule, we call it the product rule. So the product rule, you have two single logarithms, and there's a plus sign in between. In that case, we can condense these two into a single logarithm by multiplying them together. Quotient rule, you have two single logarithms, and there's a minus sign in between. And in that case, I can condense them into the log a, base a, of the n over n. This is a fraction form. That's why we call it the quotient rule. So the first term of n stay on the numerator. The second term of n stay on the denominator. Power rule. Power rule, we have the log base a of n with the degree power k. Once you have the logarithm here, this k, we can swing to the side log. Both of the base number, they all can be rewritten into the 2 to the power something. So I'm going to rewrite the 4 into 2 power 2. And then there's x plus 3 on the top. The right hand side, number a, I can rewrite the a into 2 to the power 3. And there's a 2 power 2x on the outside. Now we can apply with the a of the power x. Outside has another power y. This will turn to the a to the power xy. So now we just distribute the power part. So we will have the 2x plus 6 is equal to the power 6x. According to the rule, b of the power x equal b of the power y. In that case, I can just cross out the base. Let the degree power equally on both sides. And from here, I can solve for x. So x is equal to 6 over 4, which is 3 over 2. Now we do this equation. This question we have 3 to the power x equal 5. There's no way I can rewrite these two base number into the same base number. For example, this one, I can rewrite the 4 and a into base 2. And then I cross out the base number 2 to solve for the x by using the degree power. So 3x equals 5, there's no way I can rewrite it into the same base. So what do? I raise up log. On both sides. Let me write down here. So once I have the log raised up into it, the left hand side, I will have the log of 3 to the power x equal log of 5. There's no base number here, which is the 10. But generally with the base 10, we don't put down the 10. Okay. Now, since I have logarithm form here, or logarithm expression here, I can use the power rule to swing this power x to the front. So I can rewrite the left hand side into the x times log of 3 equal the log of 5. Keep in mind, log 3 and the log 5, they are all numerical. They're just a number. So in order to isolate the x, I just simply to divide by log of 3 on both sides. Then I solve for the x equal log 5 over log 3. And then you just type in these two numbers into the calculator. So when we have the log 5 divided by log 3, it gives us approximately x is equal 1.4650. Now we do another example here. Now we look at this example. This question has a 13 to the power x minus 1 equal 2. Same way, there is no way I can rewrite both of the base number into the same. So we raise up log. So I raise up log here. I put a log here. It's 13 to the power x minus 1. Do the same to the right hand side, has log of 2. Now we swing this power to the front. So you will have the x minus 1 times log 13 equal log 2. Now we divide by log 13 on both sides. So the right hand side, you'll have the log of 2 divided by log of 13. And then you add 1 into the right hand side. Log 13 plus 1. Then you use a calculator to solve for the decimal into the decimal number. Okay, you can do this part yourself. When you have the base e, that means this is a natural logarithm, natural base number e. So every time when you see the e, you always raise up with the ln instead of the log. Okay, because ln pair with the e. ln e is equal 1. E ln is equal 1. So now I'm going to solve for e to the power x equal 10. How do we do this question? So I saw the e here. Then I raise up ln on the left hand side and do the same thing to the right hand side. Now ln e, we can just simply to cross out. Then you solve for x equal ln 10. Log x plus log x plus 21 equal 2. Since the left hand side, there are two logarithm form. So I'm going to use a product rule to condense these two into the single logarithm. So once I condense these two, it will turn to log x multiply x plus 21 equal 2. Once you condense the multiple logarithm into the single logarithm, the next step would be get rid of the logarithm. And the way we can get rid of the logarithm, just depends on the base number they have. This question, this logarithm, we only have the base 10. We have the base 10, not only. So I raise up base 10. I raise up 10. I raise up 10 on both sides. Okay, let me erase this one. Now the 10 will cancel with a log. So now we rewrite, clean up the left-hand side and the right-hand side, 10 to the power 2, which is 100. Now the left-hand side, we distribute it. So you have the x squared plus 21x minus 100 equals 0. Now we do the factoring. So we'll have the x, 5 and 20 doesn't work. 10 and 10 doesn't work. Alright, 100, what else we can have it? 25 by 4 don't work, right? So we put a 25 and 4. Now since the middle term is a positive 21, that means the bigger number is a plus, small number is a minus. Okay. So from here, we can use the zero factor form to solve for x. That tells me x equals negative 25 or x equals 4. Now we need to do the test. So when I plug in the negative 25 back to the equation here, I will get a log negative 25. So log negative 25 is a negative number, so we cannot take the negative 25 as a solution. 4. Plugging 4 back to the equation, this is a log 4, which is okay. Plugging this 4 into the second logarithm form here, we will get a log 25. So this is log 4, log 25. Both of them, they are positive number, so we can take the x equals 4 as a solution.